An inverter circuit made using 4017 integrated, NE555 timing integrated, IRFs44 MOSFET transistors and 100-watt transformer is an electronic circuit that converts the energy coming from a DC direct current source into alternating current energy. Here is the working principle of this circuit. A DC source is connected to the input of the inverter circuit. This DC source is usually a battery, an accumulator, or a DC power supply. The energy from the DC source is given to the input of the inverter. The NE555 timing IC forms the oscillator, the oscillation-producing component, of the circuit. NE555 is enabled to operate in stable multivibrator mode. This mode will produce a regular square wave. This square wave signal determines the main operating frequency of the circuit, and when it operates at this frequency, it controls the IRFZ44 MOSFET transistors. IRFs44 MOSFET transistors. IRFs44 MOSFET transistors are the main power switches of the inverter circuit. These transistors are driven by the square wave signal generated by the NE555. The square wave signal controls the turning on and off of the MOSFET transistors. Each MOSFET transistor operates as an amplifier and a sink. As it rises, one opens, the other closes, and vice versa. 100-watt transformer. This is the main output transformer section of the inverter circuit. The transformer takes the high current and low voltage AC output signal and converts it into low current and high voltage AC output signal. This conversion increases the voltage of the AC output and increases its power. The 4017 integrated circuit is used as a counter and Decater. When the pulse signal generated by the NE555 is applied to the clock input of the 4017 integrated circuit, the output pins of the 4017 are activated sequentially with each pulse. This cycles through 10 different output targets, from 0 to 9 output pins. At each counter step, the output pins of the 4017 IC are activated sequentially. The output of the inverter circuit is taken from this enabled output target. When the input signal is connected to one of these output pins at each counter step, the input signal is inverted and transmitted to the output. The pulse signal generated by the NE555 IC can be used to reset the 4017 IC when the 4017 IC reaches a certain number. This resets the circuit to its initial state, and the inverted acquisition of the input signal at the output begins again. As a result, this circuit is used to obtain the inversion of the input signal using the combined operation of NE555 and 4017 integrated circuits. NE555 generates a regular pulse signal, which controls the 4017 IC, which inverts the input signal and delivers it to the output. This can be used to meet signal processing and sign inversion requirements in digital logic applications.